Hello friends, I'm having a PLC programming problem which is right here. Let me read this for you. A vision camera scans the pallet barcodes as they pass. The number of parts on the pallet is extracted from the barcode data and that number is transferred to a PLC and placed in a register. A bit in the PLC is turned on by the vision system when the quantity data has transferred. The total number of pallets is stored in a register. Design a ladder program that keeps a running total for pallet parts in a register and the number of pallets left in the batch in another register. Include logic for a normally open push button switch that is used to clear the total register at the end of a production run in preparation for the next batch. So that's my question. Before I move to the ladder diagram, I will explain the problem real quick. Consider there's a pallet arriving with certain number of boxes or parts. For every pallet arriving, we need to count the total number of parts arrived till a batch is completed, which means for a specific number of pallets, we need to count the total parts received. And also, once a batch is completed, we need to reset the controller to set all the values back to initial stage. So let's go and take a look at the ladder logic diagram, which is right here. I'm having a vision camera or a pallet sensor which indicates the arrival of a pallet. Then I'm having a move instruction which actually moves the value from a source to a destination. Here I'm having the source and destination. Everything is a integer register. I'm using an integer register because the number of parts in a pallet will be always an integer. It cannot be a float or some other value. It will be always a integer, so that's why I'm using an integer register. And n7 colon 0 is the source, which will be the number of parts in that specific pallet, and n7 colon 1 is the parts received. So when a pallet arrives, the pallet sensor switch gets activated, which in turn activates the move instruction. So the number of parts in that pallet will be moved to another specific location in that register, which is n7 colon 1, and will be stored as the, as you see here, it will be the stored as the number of parts received. So again, I'm having a vision sensor, vision camera pallet sensor switch, which activates the OSR instruction, that is a one-shot rising. I'm using this OSR instruction because if I am providing the pallet sensor signal directly to the next two mathematical instructions, that is a add or subtraction, it will keeps on doing the mathematical operation again and again. So I don't want to do that. I just want to provide a one pulse to that add and subtract instruction, because for a particular palette I just need one signal. So that's why I'm using the OSR instruction. Inside the OSR I'm having the storage bit as b3 colon 0 slash 1 and the output bit is I colon 1 slash 3. For the addition and subtraction, I am providing the input as the output bit of the OSR instruction, that is I colon 1 slash 3. So what this addition instruction does is this actually calculates the total parts received. So I'm having a source A as n7 colon 1, which is the number of parts received, as you see inside the move instruction, and the source B is the total number of parts received, which is n7 colon 2. So initially I am providing a value 0 for n7 colon 2. So whenever a pallet arrives, there will be addition taking place, and n7 colon 1 value will be added with the n7 colon 2, which is initially 0 and then stored to n7 colon 2. So for the next pallet arriving, the value of n7 colon 2 will be the number of parts in the previous pallet, and it keeps on going for every pallet in that batch. And finally we will be uh, getting the total parts received in that batch. Again, I'm having the subtraction instruction, and for this instruction I'm having the source A as n7 colon 3, which is the number of pallets in a batch. This is actually a value which I am providing since this is a simulation. Here I am providing the value as 50, and so this instruction works to calculate the number of pallets left. So whenever a pallet arrives, this instruction gets activated, and this subtract 1 from the total number of pallets for every pallet arriving, and so which means now I am having 50. So after 50 pallets arrive, this the value of source or the value in the destination, that is n7 colon 3, will become 0. And finally I'm having a reset switch which resets all the values back to the initial stage. So only n7 colon 3, that is the total number of pallets in a batch, is 50, will be reset to 50, and all other values inside the register will be reset back to 0. So I'm providing a clear instruction for those three, and I'm providing a move instruction for n7 colon 3. So let's go ahead and run this program. I'll show you the integer data file for better clarification. So let's say the first pallet arrives with a 10 parts. So when that pallet arrives, this value will be moved to n7 colon 1, and there will be an addition taking place, and n7 colon 2 will be stored with the 10 plus 0, that is 10, and as you see here, the total number of pallets will be reduced to 49, that is 50 minus 1, which is 49. And let's say the next pallet arrives with 5 parts. There you go. Now n7 colon 1 will be loaded with 5, n7 colon 2 will be loaded with 10 plus 5, that is 15, and one pallet is reduced from n7 colon 3, which makes it value 48, and it keeps on going. I can make the next one let's say it's 15, and when the next pallet arrives, you can see n7 colon 1 will be loaded with 15, n7 colon 2 will be having a value 15 plus 15, that is 30, and one more pallet is reduced from n7 colon 3, and this keeps on going. So when all the pallets is received, or when we are ready for a next batch, or just we need to reset in any case, just hit reset, and you can see all the values will be returned back to the initial values, that is 0, 0, 0 and 50. So that's how this problem is solved. I hope it's clear. Thank you all for watching.